Okay. All right. So I think I have a plan, and it's that try to do one section of each of these books every day, and then I'll keep up with the actual course. All right. So I won't have the first five sections, in the playlist because I already did those. But we'll start here, and we'll just go from there. All right. You might expect that a real life problem involving linear algebra would only have one solution or no solution. This shows that many solutions can naturally arise. Uh, okay, so there's three examples: economics, chemistry, and network flow. A homogeneous system in economics. So homogeneous means that the right-hand side is zero. The system of 500 equations in 500 variables mentioned in the introduction is Leontief's input-output production model. Section 2.6 will examine this model in more detail when more theory and better notation are available. For now, we'll look at a simpler exchange model, also due to Leontief. Suppose a nation's economy is divided into many sectors, such as various manufacturing, communication, entertainment, and service industries. Suppose that for each section, we know its total output for 1 year. And we know exactly how this output is divided or exchanged among the other sectors of the economy. Let the total dollar value of a sector's output be called the price of that output. Leontief proved the following result. There exist equilibrium prices that can be assigned to the total outputs of the various sectors in such a way that the income of each sector exactly balances its expenses. The following example shows how to find equilibrium prices. All right, suppose an economy consists of the coal, power, and steel sectors, and the output of each sector is distributed among the various sectors as shown in Table 1. Where the entries in a column represent the fractional parts of a sector's total output. The second column of Table 1, for instance, says that the total output of the electric sector is divided as follows: 40% to coal, 50% to steel, and the remaining 10% to electric. Electric treats this 10% as an expense it incurs in order to operate its business. Since all output must be taken into account, the decimal fractions in each column must sum to 1. Does that not mean, though, that the output for coal is the same as the output for electric and the output for steel? They're all the same. Okay. Denote the prices in dollar values of the total amounts of. Okay, hold on. Denote the prices in dollar values of the total annual outputs of the coal, electric, and steel sectors by PCP-EPS. If possible, find equilibrium prices that make each sector's income match its expenditures. Okay. A sector looks down a column to see where its output goes. It looks across a row to see what inputs it needs. Okay, for instance, the first row of table 1 says that coal pays for 40% of the coal pays for 40% of the electric output and 60% of the steel output. Okay, that makes sense. Since the respective values of the total outputs are PE and PS, coal must spend 0.4 PE plus 0.6 PS. Thus, coal's total expenses are that. To make coal's income, PC is to make coal's income PC equal to its expenses. We want. Okay, so they're just making the equations now. So this is going to be 0.6 plus 0.1 plus 0.2 is okay. All right, great. So now we have the system of equations. To solve the system of equations, move all the unknowns to the left side and combine like terms. Okay. Row reduction is next. Okay, then we get this. Okay, and now we see there's a free variable. The equilibrium price for the economy has the form. Let's see. Let me just do that manually. So we have, it was CPS. So then, or CES. This is E. CES are the variables. So we have C. Wait, hold on. It's taking me a minute. Hold on. For something like 1, 0, 2/3, 0, 0, 1, 3. This becomes like. Oh yeah, okay. Okay, so in this case, right, I always forget that part. Okay, so this makes sense. You can see this because if you, first off, it's clear that x3, which is this column, is free. So if you say x1 is equal to 0.94 x3 plus 0, because this is the solution, and similarly for x2, then you can write the solution in terms of just PS. So it's just the scalar multiples of this column. So this solution is the prices for that cause. And so what is this sum on the right side? The sum on the right side is the total output. I'm hoping you guys don't hear this super annoying construction that's going on in the background. Not that it matters. Okay, so any non-negative choice for PS results in a choice of equilibrium prices. For instance, if we take PS to be 100, then PC equals 94 and PE 85. The incomes and expenditures of each sector will be equal if the output of coal is priced at 94, 85, and 100. Okay. Okay, the second application, balancing chemical equations. Chemical equations describe the quantities of substances consumed and produced by chemical reactions. For instance, when propane gas burns, propane combines with oxygen to form carbon dioxide and water. Okay, to balance this equation, a chemist must find the whole numbers x1 to x4 such that the total number of carbon, hydrogen, and oxygen on the left and right hand side correspond. A systematic method for balancing chemical equations is to set up a vector equation that describes the numbers of atoms of each type present in a reaction. Since equation 4 involves 3 types of atoms, construct a vector in R3 for each reactant and product. Great. Okay. Yeah. And then so you can, okay, so then it negates them. That's good because, yeah, that's actually better to negate the columns. All right. Row reduction gives that. Right. I remember writing the code for this that does this symbolically. So basically you get these fractions but you need to divide by because they end up as fractions. So you need you need to take it so that it's the minimum integer valued one because you don't want rational values. Okay, great. Great. Okay, that's easy. Right, because yeah, okay. That's a very easy example. All right, systems of linear equations arise naturally when scientists, engineers, or economists study the flow of some quantity through a network. For instance, urban planners and traffic engineers monitor the pattern of traffic flow in a grid of city streets. Electrical engineers calculate current flow through electrical circuits, and economists analyze the distribution of products from manufacturers to consumers through a network of wholesalers and retailers. For many networks, the system of equations involve hundreds or even thousands of variables and equations. A network consists of a set of points called junctions or nodes, with lines or arcs called branches. Oh wow, they're really using terrible terminology here, but okay. The direction of flow in each branch is indicated, and the flow amount or rate is either shown or is denoted by a variable. The basic assumption of network flow is that the total flow into the network equals the total flow out of the network, and that the total flow into a junction equals the total flow out of the junction. For example, figure 1 shows 30 units flowing into. All right, so yeah, okay, I see what they're saying. Okay, great. The problem of network analysis is to determine the flow in each branch when partial information, such as the flow into and out of the network, is known. The network in Figure 2 shows the traffic flow in vehicles per hour of several one-way streets in downtown Baltimore during a typical early afternoon. Okay, so let me just try to do it myself. So, okay, so my guess is that x4 plus x5 is equal to 400 plus 100 because of these two things. Then x1 plus x5 is equal to 600. X2 plus x4 is equal to 300 plus x3. I like these applied ones. These applied ones are fun for me. Okay, and then what's the next thing? So there's 5 variables, right? So we have 4 right now. 4 equations. So x1 plus x2 is equal to 800. Do we have them all? Yeah. All right, cool. So this is right. Oh yeah. And the total flow. So the And then, yeah, so we have 400 plus 100 plus 500 plus 300. Yeah. 400, 500, 300, 100. So those are the four inlets. Is equal to 300 plus x3 plus 600. Yeah, x3 equals, okay. So they do this, okay, then they do this, okay, and then we end up with a free. Great, that's cool. A negative flow in a network. Okay, yeah, so yeah, the solutions must be non-negative. This fact leads to certain limitations on the possible values of the variables. Right, because of this equation, it can't be x4 can't be negative. All right. Practice problems. So this is LA 6. Maybe we'll try to do 2 linear algebra sections because I really want to stay ahead in that class because I don't know. All right. Suppose an economy has 3 sectors. AM, oh great. Agriculture, mining, and manufacturing. Okay, so the whole point of this question is to make you realize what the tables mean in that model. So let's just start with the columns. So A, MI, and MA. So 0.5 goes to, of its output goes to mining and 30% manufacturing and retains the rest. Okay, so this is going to be 0.5 on the second row and 0.3, 0.05, 0.05. Okay, so that's going to be 1 minus 0.35 for what it sends to itself. What is that, 65? So this is going to be 0.65. Okay, so then mining sells 20% to agriculture and retains the rest. So 0.1, 0.2, 0.7. Okay, and then manufacturing sells 20% to, so 0.2, 0.3, and then 0.5 to itself. Wait, that can't be right. Is that true? Actually, I think that might be okay. I don't think that the rows need to sum to. Wait, do they? Yeah, the rows don't need to sum to. If the rows and the columns sum to 1, that's definitely got a special name. But I don't know what it is. Okay. All right. So we have the exchange table. So that's easy. Okay. Now Okay, so 2 is constraints on x1. All right. X1 is here, x2 is there. Okay, so we know that they're 800. But we also know that x5 is so let's say if x5 equals 500, then x2 okay, x2 is going to be 700. And x1 is equal to 100. If x5 is 0, then you get 200. I don't really know what they're asking them. Consider the network closed. My guess would be that there's like some I don't know what they're actually asking. Let me look at the graph again. Because there's no solution of there's no value of x5 in 0 to 500 that actually causes this to be like greater than. You can't like. All right, let's look at the answer. Oh, that's all. Yeah, that's okay. That's fine. Yeah. Okay. That's cool. That's fine. All right, there's actually not that many problems in here, so we can just hammer them. All right, I'll read through some of them. Suppose an economy only has 2 sectors, goods and services. Each year, goods sells 80% of its output to services and keeps the rest, while services sell 70% of it. Okay. Find the equilibrium prices. Okay. So G and S, G sends 80, so 0.8 and 0.2, and okay, great. Now we're trying to find the equilibrium prices, which, what does that mean? Like, why would you even want to find the dollar values, the outputs of the sector that cause it to be 0? I sort of understand what's going on, but I mean, doesn't it imply something like there's zero growth or something, maybe? I don't know. All right, so this is going to be like 0.2 g plus 0.7 s is equal to 0. 0.8 g plus 0.3 s equals 0. Am I missing something? I think there's exactly one solution, if it exists. So we're going to do R2 minus, just do this. Oh, geez. Hey, you know what? I don't know if I committed my code. That's fine. Yeah. Okay. So what is this? Is 0.2, 0.7, 0.8. I guess we can do this. So they're going to stay 0, so it's not that important. What just happened? Dude, what are you fucking talking? God, I hate this. What? Such a terrible, terrible language. It's just, I don't know why Python is like so bad. Like, if Python was just not so bad, then I wouldn't have to use this. But Python is so bad. Okay. I don't care. Not a big deal. All right. Wait, why am I... Find prices... Yeah, I'm missing something. There's no free variables, so... What does that mean?
But you're doing some crazy math over there. What are you doing?
Yeah, just
Stuff that I never got to when I went to school. Stuff that my son is like far advanced like you. He's like he's got this like triangle and all this stuff. I'm like, ask Google and ask that. I got you this far.
Yeah.
So I'm just here to wait for the inspector to extend the inspection. I'm gonna get rid of that file of it. What are those traps for? Those are, I think, four. I want to catch a stone.
Okay. Might look. It might be a little small.
I don't know, but from what I saw on Amazon, right, it's really sharpened. It's a tube, so like it captures them and you don't get sprayed. But then what do you do with them?
Yeah.
Do you like let them go somewhere? Or I was thinking just put them in water and drown and kill them.
Yeah. So.
Or it's a one use, just throw them away.
Yeah. What my dad does is he has this stuff.
No, it's coming like through the catching on the so he comes out of the hole, because we're at cul-de-sac. So he comes out of the sewer and he comes right across the road. And then 4 months ago, so it just takes off. I don't hear any noise. So, but it's like Bruno, because he normally comes in and I was like, it smell. But it was burning rubber. It wasn't silk smell. So he ran to the side, went into the garage, and ran in the house. My wife comes out. She goes, "Oh my God!" He ran in, and the lady next to her, so he got sprayed with it. Oh,
Yeah.
You're up until like 1 o'clock. Beat up, and then like 2 or 3 weeks, and it's later.
Yeah.
Oh, it's trying to do. And it's like, that's, for a minute there, I was thinking, like, when I had on the hands up, I was looking at the dispenser. So,
Yeah.
you know what I mean? I'm like, I'm good. I'm good.
Yeah.
Oh,
yeah.
We have to go for this. I have talked about this store, we get ready to go. Grab the cane, grab the shovel.
Yeah.
Yeah, we opened the store, graveyard. Yeah, we can get graveyard. I gotta get my fruit. Yeah, they're probably. You know,
See, but if there's oh wait. Oh. If there's no free for a homogeneous equation, okay, this is that application of that theorem. I understand number 2 now. There is no solution besides the trivial solution. There is no prices that there's no price for these outputs that balances the equation because, as we know, that a homogeneous system with no free variables only has the trivial solution. So that's where that's about. So we're good there. So basically, okay, so we're just doing the questions now. We're just gonna do most of these questions because I feel like they'll be like good thinking problems. This is 1.6 exercises. So, no free variables implies if and only if only only trivial solution. Okay, so we're good there. So the prices must be just 0, which is obviously wrong. Which to me just means like the model is wrong. Like the only way you get any insight, I feel like, into that is if like it doesn't tell you anything, I guess. All right, find another set of equilibrium prices for the economy in example 1. Suppose the same economy used Japanese yen instead of dollars to measure the various sectors' output. No. It doesn't matter. Okay, 3. Consider an economy with 3 sectors, chemical and metals. So we'll say C, F, and M. C, F, M. Chemical cells. Okay, so 0.3 and 0.5 it said. And fuel cells 0.8 to chemicals and 0.1 to machinery. And machinery 0.4 and 0.4. So you're going to get 0.2 on the diagonal, 0.1 on the diagonal, and 0.2 on the diagonal. Okay, great. So now, what are we trying to do here? We got the exchange table, so that's all good. Develop a system of equations that leads to prices at which each sector matches. Develop a system of equation that leads to prices each sector's income matches its output. So, okay, so I actually want to know. Let me get some more coffee in a second here, but I'm pretty sure that we're going to get the matrix. So this is going to be number 3. So it's going to be A is equal to, and that's going to be 0.2, 0.8, 0.4, 0.3, 0.1, 0.4, 0.5, 0.1, 0.2. Somehow, it's so funny how ChatGPT knows, or whatever. Okay, so that's fine, but it doesn't really, I mean, it just, all this tells you, I mean, instead of even doing I could just say, what is the rank? Then we'd see that it's 3, so it's like full rank. But anyways, but what I'm trying to understand is, right, that leads to prices at which each sector's income matches its expenses. So my understanding is that I would say PC is okay. C is where its output goes. and it looks across the row to see what it needs as input. So for instance, it says that coal pays for 40% of the electric output. Right. So like PC should be equal to 0.2 times itself plus 0.8 times PF. Wait. Okay, so wait, I'm just gonna write it in English because then so what I don't know what it's called, but C needs 0.2 of C output, 0.8 of F output, and 0.4 of M. F needs, 0.3 C plus 0.1 F plus 0.4. And CF and M are all prices. They're all amounts of money. Um, these are actually pretty old. I don't know. That's tough. The whole idea of making it income equal to expenses is kind of weird. So the income is the whole column sum, and you set it equal to the row. Okay, all right, I get it. Right. So alternatively, we could have said like 0.6 PC, or whatever, 0.2 PC plus 0.3 PC plus 0.5 PC. But we just know that each column sums to 1 because um okay. So I have the exchange table. It's this one. I'm pretty sure that Even if I did add the zeros, it doesn't actually change anything. But if I added, so that we're saying find a set of equilibrium prices when the machinery output is 100. So M PM equals 100. So if this is uh okay, I think I'm gonna do this because wait. Chemicals goes 30%, 50%, and 20%. Okay, yeah. Just hold on. What? Oh, they have it transposed. Let's just see if we got the same. Income of C. Okay. Oh yeah. So if we have this matrix, Oh, right. Okay, wait. So if we so okay, let's write the equation. Okay, so it should be 0.2 x 1 plus 0.8 x 2. Is it minus? I don't think that I did this right, but why is it minus though? Yes. Yes, I am. I'm gonna get another cup of coffee. Okay. This thing is tripping me. I don't even want to use this. I just want to read the textbook again. So, well, actually, I wanted to ask O3 about this. Oh wow, they got the O4 now. Cool. I just saw the video about it. Right now, biology. I mean, this is linear algebra and differential equations, but you know, eventually biology. I hope O4 mini doesn't take as long. It takes way longer. What the heck? 27 seconds for response is kind of insane. Okay, yeah. So I did number one. I did number one. Wait, but when they do the retain thing, all right, let me read this again. So these are the equations that balance the basically the amount of money they get for selling 60% of their output. And or 60% of the output plus yeah. Okay. Okay, so these are the equations that balance for each sector the input and the output. Which honestly I just don't even understand why you do that. But let's just try this again. So I don't like how GPT is doing this with the retaining just being subtracted from the. It actually simplifies things because you can just remove it, but I'm not going to do that. So 0.8, 0.7, 0.2, 0.3. Okay. So in this thing, we're going to have that the price. So this is going to be goods and this is services. So PG is going to be equal to 0.2 PG plus, and does that show up above? That we have PS contains PS in it. Okay, that's fine. Plus 0.7 PS. And then PS is equal to 0.8 PG plus 0.3 PS. Okay, so what we have now is 0.8 PG minus 0.7 PS is equal to 0. And why? So these. Okay. Oh wait, I did this wrong. Okay. 0.8 minus 0.7 minus 0.8 0.7. Okay, so yeah, I was like, uh, I was not, because this table is not the matrix that you do the row reduction on. Okay, so that's where I was confused. Biology. No, I was not successful. I got denied from pretty much everywhere. So I'm gonna do one more year, get transfer app guarantee. Because if you take all the right classes, you get a certain GPA. So the whole point of all of this right now is to boost my GPA. Hopefully we can get it high enough. I don't know. It's honestly unclear. Even if I get all A's, I might not be able to get it high enough. But biology is really cool. Mathematical biology is really cool. But no, applications were brutal. Did not go well. All right. All right. So I understand what's going on here now. So uh, so we should be able to do okay, great. So let's rewrite this thing. So this is the exchange table. Okay, but what we actually care about is the equations. So let's just do variables GS. Okay, so what we want is that G is equal to 0.2 times G plus 0.7 times S. And this isn't going to work. That's, no. See, we shouldn't have done that. These are the equations. You have to do it like this. And S is equal to yes. Okay, so then you arrive at. Thank you, man. Appreciate it, Nikita. It's my notes highlight. I don't know if I'm qualified to be handing out advice. I don't know. Who knows, man? All right. All right. So in this case, so then we end up with the matrix where if if we move everything to one side, we end up with the actual matrix, which is going to be 0.8 minus 0.7, right? Then point minus 0.8, 0.7. And I guess now here we want those to be 0 because we made the equation. So then here we can RF this, and that will actually show us that we have the free, that we have, x1 is equal to point, whatever, 7/8 x2 with x2 free. All right, so this is the actual solution. So we finally did one problem. All right, cool. But that makes sense now. I understand where my confusion was at. You can't just like take the exchange table. You have to actually, you have to say that what I want is that the inputs and the outputs are equal. And that only happens if you make new equations. Okay, so I'm gonna do it again. I used to think that I could just like know it all, but actually I kind of have to grind nowadays. All right, okay, let's just do this thing. So we have, we're gonna do it again. So this is CFM, CF and M. Okay, 0.3 and 0.5. Or you know what? I'm just gonna do it on here. So okay, so this is number one. So let's do this up here. So 1.6 number one. Oh wait, and this is the exchange table. Oh wait, I thought I wrote down the. I thought I did, but I didn't. Okay, fine. So number three, the exchange table is. It's gonna be I have it. 0.2, 0.8, 0.4, 0.3, 0.1, 0.4, 0.5, 0.1, 0.2. Okay, so this is the exchange table. And if we have variables, what is it, CFM, then the equations we're going to get are that C is equal to, or it's going to be, yeah, 0.2 plus 0.8 plus 0.4 M. F is 0.3 plus 0.1 point. Okay, so these are the equations. So then what we should be able to do is say, I think if I do this, let's say E is equal to this, just whatever, E dot, okay, so um, so I think what I want to do is, isn't there a, okay, whatever. And I'm pretty sure that I can do like that. Okay, so now we're trying to do this. Okay, great. So now we have the equations. So now, I how we can do this. Anyways, okay, so A is going to be equal to wow, how does it know that? But that is right. Minus 0.5 minus 0.5. Okay, so that's right. So this is the table. So now this table we can take the RF of. Okay, great. I wish it was oh, you know what we should do? We should do it as integers. What? Really? I don't like that, man. Womp womp. Um, well, anyways, we could just leave it as that. It's fine. So that those are the equilibrium prices. So for 3, the equilibrium prices are like x1 equal to, looks like the square root of 2, but I don't really know if that's, probably not that. 1.41 x3, x2 is equal to 0.91 x3, and x3 is free. So the solution is going to be 1.41, 0.911. So basically, any prices for any x3 that are in that ratio will constitute an equilibrium price. Yep. Okay. Number 4. Suppose an economy has 4 sectors: agriculture, energy, sectors. All right, so it's another one of these. All right, we should be able to just like smash it because now it's pretty easy. All right, so A, E, N, T. A sells 10% to E. 0.1, 0.25. Okay, so 0 to transportation and retains the rest. Okay. Um, in T, 0.2, 0.1, 0.3, and the diagonal. So this is going to be 0.65. This is going to be, let's see. Okay, yeah. 44, this is 0.25. Let's see. 0.3 plus 0.1. Yep. Oh, no. 1.5. Yeah, 70, 85. Okay, and then this. All right, so this is number 4. So our exchange matrix is going to be equal to 0.65, 0.3, 0.3, 0.2, 0.1, 0.1, 0.5. Okay, and then I want to do. Let me make sure that that's okay. So wait, really? What? How is that possible? I think I have to do this. Oh, there we go. There. Okay, so that's fine. So okay. Um, we need to make the equations. Okay, great. So I think I'm gonna just start by. Okay, so let's just do this again. This shouldn't be too. A, E, M, T. Or actually, we don't want A. Let's call it X. Because A I like to use for matrices. So then the eeks are going to be, yeah, exactly. So what this is saying is that if you wanted to buy the entire output of the sector X, which is agriculture, then we're setting it equal to buying the component, the corresponding inputs. All right, so that checks out. So now we can do f dot eeks. We can look at this. Is that gonna work? That's actually kind of dumb, right? Why shouldn't you be able to do scalar multiple of an equation? Maybe that's not always valid. I'm not sure. Okay, so those are the equations. So let's just write them down. So we get this. So, wait, why did it? Wait, we want. It sorted it. X. Nice. That's awesome, man. All right, so I want to do, but I want to do 100 times this. Oh, you can't do that? I think I have to do this. Okay, now I have an integer matrix. Now I can RFA. I think I'll still get, okay. I think I want to, ask. I'm pretty sure, I mean, I'm getting that there's no non-trivial solutions to this economy for equilibrium or whatever. Wait, hold on. Let me give it the actual problem. Okay, let's just make sure that we got the same. So A. Oh wait, did I? I think I did this wrong then. I think I misread the. Wait, what? see, so you get 0.3 equals, okay, so yeah, I got this. So the equations seem good. The only thing they do is they just remove the diagonal because it shows up on both sides of the equation, but that's totally fine. Okay, so yet again I did this thing wrong. Um, let me try to um, um, okay. All right, wait. I'm just gonna do it all manually. It's fine. I'm gonna do it one more. So we're gonna get 35. We're gonna move them all to one side. So let me just look at the eeks. Oh, okay. But I wonder. I probably can do 100 dot times this, right? Ugh, gosh. Okay, whatever. That's fine. Um. Okay, so 35a plus or minus 30e minus 30m minus 20t is equal to 0. That's the first equation. The second equation is 10a minus 10a plus 90e minus 15t m minus 10t. Okay. Let's just finish writing them out. So where were we? We're on m now. So minus 25a minus 35e plus 85m minus 30t. So yeah, let's just say t equals 1. That's the easier thing. And then okay, the last one. This is going to be 0 minus 25e minus 40m plus 60t. Okay, so now if t is 1, so I guess that's part of the trick of like solving these problems is that you need to um, um, just set one of them to some value and then you can get the ratios because otherwise it doesn't make sense. So what we're going to do is it's going to be like 35a minus 30e, or we can move them to the other side now. Oh wait, actually I don't want to do that. So okay, so once we set t to 1, let's just rewrite the equation. Minus, minus, and then we're going to move the constant to the other side. Okay, so we should get something like 35 minus 30 minus 30, 0, 20. Yeah. I think so. Oh, really? Wait, how did I do that? So, oh wait, I'm pretty sure that this needs to be minus 60. Still no dice. Because right, because we should get a solution that's like t times a vector like a b c d. What did they do to solve this solution? They were able to um, dude, 04 mini high actually takes way too long. Maybe I shouldn't use high. Maybe I should use just the 04 mini. Yeah, this is taking way too long. I wish they had an answer for this one. Whoa. Oh, you know what? Wait. No, I actually don't know. I'm so confused right now. Oh, really? You just get rid of the last equation? Is that true? I didn't know that. So wait, if I did RF of A2, wait, if I just get rid of, wait, okay. I'm gonna copy it. Wait, and then we just get rid of this. Is that right? See, I didn't even get the right answer. What? What happened? Oh. They didn't even have this in the book then. That one's weird. All right, let's move on. Balance the chemical reactions using the vector equation approach. Okay, so we have. So what atoms do we have? We have boron. We have sulfur. We have hydrogen. We have oxygen. There's 4. Okay. So that's the order it's going to be in. So we're going to get 2, 3, 0, 0, and this is going to be x1 plus x2 times 0, 0, 2, 1 plus x, and then it's going to be minus, or no, it's going to be plus x3, and then we're going to negate all the other ones. So we're going to get minus 1, 0, minus 3, minus 3, plus x4, 0, 0, wait, no, 0 minus 1 minus 2, 0. Okay. Right, so number 5. I don't really care how I do this. Or we could just write the matrix actually. 2, 0, minus 1, 0, 3, 0, 3, 0, 0, minus 1, 0, 2, minus 3, minus 2, 0, 1, minus 3, 0. Okay, so these are and we basically just want to make this a homogeneous I think this works, right? Okay, cool. All right. So see, this one was so much easier to me than that economic one. I hope that doesn't show up on a test because that one really tripped me out for some reason. I don't know why. Okay, but so here we can see, um, okay, so x1 is equal to 1/3 of x4. X2 is equal to 2x4. X3 is equal to 2/3 x4. X4 is free. So what I'm going to do is multiply everything by 3. So we're going to get 3x1 is equal to x4. Uh, 3. Let's just multiply by 6. 6x1 is equal to 2x4. 6x2 is equal to my goodness. I'm so out of it today. It's crazy. X1 Okay, so the balanced equation I think is going to be, let's look at the equation again. It's going to be, so x1 is 1, so it's going to be b2s3 plus, and then x2 is 6, h2o, plus, or it goes to 2 h3bo3 plus, the last one is 3. 3 H2S. Let's make sure that that's right then. So we have 12H, 2B, 3S, 6O. That's on the left-hand side. On the right-hand side, we have 2B, 3S, 6 plus 6H, and 6O. All right, cool. Yeah, so it's balanced. So the coefficients are 1, 6, 2, 3. All right, that's pretty easy. I know how to do those. Those aren't so bad. I think I'm gonna like the network ones. The network ones are fun for me. Ugh. Ugh. Oh, it's such a beautiful day. Should I do another one of these, or do we get the idea? I think I'm gonna just go on. Okay, let's do 11. Okay, so let's set up the system of equations. So the first one is just going to be the total inputs and outputs. So 80, which is the input, is going to be equal to 20 plus x4. So x4 is a 60. Now, 80 is also equal to x1 plus x2. And x2 is equal to x3 plus x4. And 20 is equal to x1 plus x3. All right, so I think that's all of the equations. So let's just start to write this and move them all to one side. All the variables, that is. Okay, so I think I got the augmented matrix for this thing. So I'm gonna write it down in Right, so this network is gonna have the so this is 11. So the augmented matrix is going to look like this. It's going to be 1, 1, 0, 0, 80. 0, 1, minus 1, minus 1, 0, 0. 1, 0, 1, 0, 20. And 0, 0, 0, 1, 60. Oops, did I do something wrong? Okay, now we can just RF this. And the RF of aug is, so we're going to get x1 so interestingly, the x3 is the free one. Okay, so x1 is equal to 20 minus x3. x2 is equal to 60 plus x3. x4 is equal to 60, and x3 free. So if we were to write this in our thing now, we're going to get 20 minus x3, 60 plus x3, 1, or x3, and 60. So then that turns into the what's it called? That parametric vector form. Parametric vector form is, I think, in this. Parametric vector SU plus TV. So it's going to be 20, 60, 0, 60 plus x3 times minus 1, 1, 1, 0. All right, so I think that the parametric vector form is going to look like 20, 60. Oh, I think I have to do commas. Let's see, 20, 20. Yeah, that's a 1 by 2. Okay, so these are the solutions. All right, cool. Let me get a jacket. I'm cold. All right, we're almost done with the section. Um, oh, what is the largest possible value for x3? The largest. Yeah, if x2 is greater than if x3 is greater than 20, then we get a negative number for x for the flow through this node, I think. I've never done these network problems. They're actually pretty fun. They're satisfying, you know. Wait. Wait, I don't think that this is going to work. If you close this, then you have to allow negative values through something. But actually, there's nowhere for it to go. I think that's impossible. I don't get that. Okay. Let's just do one more, maybe? Oh, wait. Oh. For some reason, I thought they were talking about the other one. Okay. Yeah, yeah. Okay. And this one, that's probably fine. That is definitely an English roundabout. There's no way that's. They don't drive on the right side of the road. Should we do that one of these? I don't know. All right, let's just do number. All right, let's just do number 14. What's the big deal? All right, and then we're going to switch to differential equations, section 1.2, and maybe 1.3. All right. Whoa. Okay. 50 plus 150 plus 100 is equal to 100 plus 120 plus 80. Is that true? That's going to be 300 is equal to 300. Okay, so so we verified that. Oh, this is a cool one. I like this one. All right, so let's just start with x1. X1 is going to be equal to 100 plus x6. Okay. X2 is equal to x1 minus 100. X3 is equal to x2 plus 50. X4 is equal to um, x3 minus 120. X5 is equal to 150 plus x4. And then finally, x6 is equal to x5 minus 80. That's cool, man. All right, so let's try to make the matrix. So we're going to have 1, all right, so x1, x2, x3, x4, x5, x6, and then beta. It's going to be 0, 0, 0, 0, minus 1 equal to 100. Okay. The second equation is x2. So we're going to have minus 1, 1, 0, 0, 0. 0, minus 1, 1, 0. And that is 6. This is going to be equal to 50. And then, oh, it has a cool like banded structure to it. That's actually fun. Okay, and then here we're gonna get 0, 0, 0, minus 1, 1. And then last but not least, okay, that's cool. So, okay, so this is going to be number 14. So, or let's just say A is equal to, and then it's definitely one of these special matrices. They had a whole bunch of examples in here. This Vandermonde one is so cool. I had to use this earlier. It's so cool that it has such special structure that you can do it in n squared instead of. Okay, so it doesn't have the banded structure. Okay, so let's just write it out. Okay, so 1, 0, 0. Wait. 4, 5, 6. This is going to be minus 1, 1, 1, 2, 2, 3, 4. Is that right? Well, 100 minus 150 minus 120, 150 minus 80. Okay. All right, this is actually the whole augmented matrix, but we can just do. Okay, cool. So yeah. So x6 free. So the whole solution is going to be like this vector 100, 0, 50, minus 70, 80, 0, plus x6 times, it's going to be x1 is equal to 100 plus x6. So it's going to be 1, 1, 1. I'm pretty sure it's that. It's just going to be like pretty sure it's just this. All right. That is section 1.6 of linear algebra and its applications. Let's see, how long have we been doing? 2 hours. Okay. Let's see, what time is it? 12:01. Okay, so yeah, so we'll end there, and then I'll start differential equations in a minute.